For this problem, we have a function f of x equals 4x cubed minus 28x squared plus 46x minus 30, and we're trying to find all of the zeros. So the first thing I'm going to do is throw this into the calculator and see if there are any zeros apparent in the calculator. I can use calc 0, and I found that x equals 5 is a 0. So next I'm going to factor out the factor x minus 5 by using synthetic division with the 0, 5. And my coefficients that go along the top row for my synthetic division are 4, negative 28, 46, and negative 30. So first I'll drop down the 4 and multiply 5 by 4 to get 20. Add negative 28 and 20 and get negative 8. Multiply 5 and negative 8 to get negative 40. And then add 46 and 40 to get 6. And last, multiply 5 and 6 to get 30. And these will add up to 0, which is what needs to happen when we have a 0 that we're using with synthetic division. So basically, just remember that what this has told me is that my function f of x, if I factor out x minus 5, I am left with 4x squared minus 8x plus 6. Now, one thing I noticed real quick is that I probably could clean this up a little bit, and I could have actually back here noticed that at the very beginning, all of those coefficients are divisible by 2. So it'll just be a little easier to work with the smaller numbers that I get by factoring that 2 out. Now my quadratic that I'm left with is 2x squared minus 4x plus 3. Now, if I'm able to factor 2x squared minus 4x plus 3, that's going to be the easiest way to find my zeros. But it doesn't look easy to factor, and then what's more, when I was on the calculator, it didn't really look like there were other very nice factors. In fact, it didn't even really look like there were any other zeros at all. So my prediction is that this will actually be complex zeros. So what I need to do to find the remaining zeros is just solve the equation 2x squared minus 4x plus 3 equals 0, because the solutions to that equation will give me any remaining zeros. And I'm going to solve that by using the quadratic formula with a is 2, b is negative 4, and c is positive 3. So I'm going to come up over here to the side and do negative b, which is negative negative 4, plus or minus the square root of b squared, which is negative 4 quantity squared, minus 4 times a, which is 2, times c, which is 3. And I divide that entire thing by 2a, which is going to be 2 times 2. So I'm going to clean that up a little bit. My negative negative 4 becomes a 4, and then I have plus or minus 16 minus 24, which actually will give me a negative 8 underneath the square root, all over 4. Now, I want to tidy up the square root in 2 ways. One is I want to factor out any perfect squares. So that will factor the 8 into a 4 and then a 2. And I want to break out that negative because that will become I. So this turns into 4 plus or minus 2 square root of 2I, all over 4. Now, with imaginary numbers, we often like to have the real and imaginary parts separate, so I'm just going to break this fraction up into 4/4 plus or minus 2/4 square root of 2i, and that will tidy up to 1 plus or minus 1/2 square root of 2i. I could also write that last part, if I wanted to, as square root of 2 over 2i. Either way is fine. And because what this accomplished was solve this equation, which is the quadratic equaling 0, these are zeros for my original polynomial f of x. So the zeros of f of x are 5, 1 plus square root of 2 over 2i, and 1 minus square root of 2 over 2i. If a problem were a little bit different, this is the final answer to this question. However, if this problem were a little bit different and I was asked to find the factors, like to fully factor this, so I'm just going to do a little side note here. What this means is that the factorization is going to be 2 times x minus 5 times x minus 1 plus square root of 2 over 2i times x plus quantity 1 plus square root of 2 over 2i. But that's not what this problem is asking, so I'm not boxing that. However, it's only one step beyond finding the zeros, so I just wanted to take this opportunity to share that as well.